I saw a lot of people not quite sure what to do with problem number 3. So one thing that I want to identify here is that this is not giving you a piece of information that you really need very directly. We're talking about the scale reading that 705.6 newtons when the plane is moving horizontally, so not accelerating up or down. So what they're trying to say is that when the normal force and gravitational force acting on this person who's standing on the scale inside the elevator, and not elevator, I'm sorry, inside the plane. Now I will make this into a plane. See, there's our plane. Yeah, okay, great artist. When these two forces are equal and balanced, and there is no net force acting in that y direction. Hang on. Can you back up a little? No, you can't. Okay. Can you at least erase that so that I can turn that into a y? There we go. What I'm saying is no acceleration up or down. When that's all 0, then that tells me that the force due to gravity is equal to 705.6 newtons. And so the reason that that is useful information is because then I can determine what the then I can determine what the mass of the person standing on the scale is, because I know that Fg is equal to mass times the acceleration due to gravity, mg. So if I know that the scale is reading this 705.6 newtons, then I know that I can find out the mass of this guy, and that is going to be 705.6 newtons divided by 9.8 meters per second squared, that acceleration due to gravity. I can find out the mass of the guy, which should be about 72 kilograms. Once you have that piece of information, then you have to go back to the problem and remember, okay, so what is the scale reading when we're accelerating at different rates? And so some of the information about the acceleration that they give you is that when the scale is reading 950, we want to look at that. So the scale is reading 950, which tells me that this guy who's normally just 705.6 newtons, he's weighing more. That tells me that the acceleration has to be upward, because it causes him to push down harder on the scale. That's what this is meaning. Okay, so let's go back and we'll try to solve that part there. So we have that the scale is reading 950 newtons. So if the scale is reading 950 newtons, then that tells me that his force is much bigger in this case. We know that if we add his actual weight to that, the force due to gravity, which is that 705.6 newtons, but negative because it's acting downward. You'll notice that I didn't use the negative symbol right here, And you may be wondering about that. Well, the reason that I didn't use the negative symbol here is because, because this, it depends on if we're talking about this as the normal force or as the weight. Right here we are technically talking about it as the normal force, or as the weight, which means that I should have technically made this a negative as well, and the negatives would cancel. And I'm looking at a mass, and because I know that mass is actually a scalar, it doesn't have a direction, I don't always worry about canceling out my negatives if that's the case. So that's a little shortcut that I took, maybe a step of laziness that I took. So if you're wondering why there's no negative here or here, it's because I was lazy. But back here, I now have that negative in front of my 705.6 newtons, because what I'm thinking about are the forces acting on this guy in the airplane. He's got 705.6 newtons of force acting down. No matter what, he always has that acting down. When we had that situation where the airplane wasn't accelerating up or down, it was just flying horizontally, then the normal force was a positive 705.6 newtons. And so this was able to be zero. The sum of the forces was zero. But now the sum of the forces is not zero. It is this 950 newtons plus a negative 705.6 newtons, which is always going to be that force due to gravity. And so then I can find out what my force is, the sum of the forces acting on this person at this point. And that value is 244.4 newtons. And that is the sum of my forces so far. That's not the question, though. The question, though, is what is the acceleration of the plane? So this value here is going to be equal to the mass of the person, though, times the acceleration of the plane. And remember that I told you the mass of the guy is equal to 72 kilograms. So now I'm going to plug in 72 for my mass here, divide both sides by 72, and then my acceleration is going to actually equal about 3.394 meters per second squared. And it looks like I'm running out of space here, but it's 3.394 meters per second squared is what you should get. And you are going to have 4 significant figures, because in our original problem, all of these numbers that are stated here have 4 significant figures.